Welcome to our webinar. This webinar is a part of a project funded by European Union Sea Breach Program. So webinar one will be about composite industry and sustainability. So we know that the composite materials play a critical role in many industries due to their superior properties such as uh, lightness, durability, and some good mechanical properties. So composite materials can be used in many sectors, including aviation, construction, uh, wind energy, and construction. So they can provide many advantages in terms of their performance, and at the same time they have some environmental impacts such as other conventional materials. So when we talk about sustainability, we know that the sustainability is gaining importance in every field of industry today. The composite industry must also keep up the latest changes in the industry. And at the same time, circular economy aims to minimize waste production and optimize the raw material use by increasing the resource efficiency. And on the other hand, there are some regulations such as Carbon Border Adjustment Mechanism (CBAM) developed by the European Union, and that regulation necessitates the integration of policies that aims reducing the carbon footprints into the industry. So in this webinar, we will examine the relationship between the composite industry and the sustainability and how these concepts such as circular economy, resource efficiency, and CBAM can create some changes or transformation in the composite industry. So if you look at the composite materials, there are many sectors, as mentioned before, that these materials can be used. One of the sectors is automotive industry. So the manufacturers of the automobiles are gradually turning to lightweight materials to increase the fuel efficiency and reduce emissions. And carbon fiber, reinforced polymer, and glass fiber, reinforced polymer composites are used in automotive industry in body panels and such as in other structural parts. And also in the electrical vehicles, the use of composites materials uh, will gain some more importance. The other sector that the composite materials are used are aerospace industry. Because of the lightness and durability, uh, this kind of materials will be very critical in the aircraft structures. We know that some of the uh, airplanes, such as Boeing 787 and Airbus A350, uh, are are using composite materials in their structures. And marine sector is one of the sectors that uses composite materials. Glass fiber reinforced polymers and also carbon fiber reinforced polymers are used in many parts of the uh, many parts in the marine sector. They can also be used in construction and infrastructure, and also renewable energy sector uh, uses composite materials such as wind turbine blades, for example, are one of our some main applications of the composite materials. So these are the main sectors that the composite materials can be used. So in the table, we see that the advantages and disadvantages of the composite materials compared to the traditional materials. or conventional materials, let's say. When we say conventional materials, we usually mean the structural materials such as steel, aluminum, and other commonly used alloys. When we compare the composite materials to traditional materials in terms of weight, we see that the composite materials are lighter since they have lower density and they have higher specific strength compared to steel and aluminum alloys. And they have better resistance to corrosion. That's why they have lower maintenance costs. But the conventional materials will require coating and maintenance against corrosion. When we compare the production cost of the composite materials to conventional materials, we see that the composite materials will need higher initial investment cost, but since they require low maintenance cost or less maintenance, let's say, they could be advantages in the long term. So in terms of formability, so the conventional materials, since they're metals and alloys, they're easier to shape, but in terms of complex geometries, we can say that composite materials are better to be formed into the complex geometries. And we compare the recycling property of the composite materials and traditional materials or conventional materials. We see that the conventional materials are easier to recycle. Um, Composite materials are more difficult to recycle, uh, but with the developing technological uh, methods and in capabilities in the future, composite materials could have also some advantages in terms of recycling, such as conventional materials. Uh, so sustainability, why is sustainability is important in the industry? Um, so the rapid development in the industry brought some global problems such as depletion of natural resources, environmental pollution, and climate change. So that's why it it becomes a necessity, a requirement to make some progress on the processes that will be less harmful to environment. That's why the concept of sustainability and the applicable models in the industry towards sustainability would be a good choice to do that. So when we when we look at the sustainability, we can define the sustainability is an approach that aims to meet today's needs while ensuring future generations access to resources, which means that we will use the sources, but it may not negatively impact the resources of the future generations. So normally it has three main pillars or three dimensions, such as environmental dimension, economic dimension, and social dimension. So when we look at the environmental dimension, so the things about natural resource, reducing carbon emission, and waste management stuff, these are the things that can be mentioned in the environmental dimension. In the economic dimension, we can talk about the resource efficiency and long-term profitability of the processes or the materials, cost optimization, green technology investments. These are the things that can be defined in the economic dimension. And for the social dimension, uh, issues such as worker rights, safety, and some ethical problems or ethical issues can be mentioned in the social part of the sustainability. So What are the critical points in terms of sustainability in composite production? So even though the composite material production provides higher durability and longevity compared to traditional materials, it faces some critical issues, uh, so such as raw material use and alternative materials. So this part includes using bio-based resins instead of fossil-based resins and evaluating renewable fibers such as flax, bamboo, fibers, etc., and integrating recycled composite materials into production. So these parts are related to raw material use. And the other category in the critical points is the energy and water efficiency in the production processes. So using low energy alternatives instead of energy intensive processes, such as using resin transfer molding compared to autoclave processes in composite industry, or closed loop cooling system compared to open loop cooling system in terms of uh, water efficiency. The other category that can be mentioned in the critical points is the waste management or recycling. So reprocessing of the production waste, for example, or the recovery of the raw materials are this type of points, or the reuse of the composite waste through mechanical or chemical recycling methods are also. So also developing new technologies for end of life management can be also considered in the waste management or and the recycling stuff. And this, in terms of the carbon and CBAM compliance, calculating and reducing carbon emissions strategies, and transitioning to low carbon production methods, and also evaluating carbon offset mechanisms. So considering these critical points, both technical and administrative changes need to be implemented to ensure sustainability, or let's say more sustainable production in composite uh, industry. So so we can say that the sustainability is one of the most important concepts, and it shapes the future of the industry in many areas. So as part of this transformation, so the composite industry must adapt the circular economy models, reduce environmental impacts, and also should increase the resource efficiency at the same time. So when we look at the circular economy and resource efficiency concept, we can say that the industrial production has remained dependent on the linear economy model, uh, based on the logic take, produce, and throw away for many years. However, as mentioned before, the rapid depletion of the natural resources and the increase in the waste and the negative impacts on the environment have revealed the need for new economic model. So circular economy is a kind of solution offered for this purpose. It aims to minimize waste and use resources in the most efficient way. So in this part, we will look at the basic principles of the circular economy, the problems of the composite industry in the current linear economy model, and how resource efficiency can be achieved in the composite industry. So as we said before, the circular economy aims to ensure the sustainability by reducing natural resource consumption, and it aims to extend the life of materials and products and integrating recycling system. So the circular economy has three main parts. One of them is reduce. the other part is reuse, and the third part is recycle. So for the reduce part, less raw material and energy consumption in production, design and production techniques that will minimize waste production and preventing resource waste by using more durable and long-lasting materials. These are the some parameters that can be mentioned in the reduce part. For the reuse part, we can say that repairing products or reusing them for different purposes could be a good option for this, or evaluating industrial byproducts in different sectors. And making parts replaceable, for example, could be a good solution. Reusable with a modular design approach. These are some solutions for the reuse uh, category. And for the recycle category, um, reintroducing expired materials into production processes. So evaluating waste with mechanical, chemical, and thermal recycling methods, and using recycled raw materials in new products could be some possible solutions. So in line with these principles, the adoption of circular economy practices in the composite industry has utmost importance in terms of more sustainable manufacturing. Okay, what are the problems of the linear economy model in the composite industry the other as in the other sectors? So the traditional model, the traditional linear economy model consists of the raw material extraction, then use them in production, use of these products by the end users, and just waste. However, this system leads to environmental economic problems in the long term. One of them is rapid depletion of natural resources. For example, in terms of or in composite industry, let's say, fibers that are made of carbon, glass, or Kevlar, and resins used in the composite production are generally of petrochemical origin. So dependence on fossil fuels and raw materials uh, increase production costs. The other problem is waste management. So thermoset composites, for example, are generally not recyclable, which results in large amounts of waste. Sustainable disposal methods are limited for now for the large composite parts such as wind turbine blades or aviation components. The other problem with the linear model in the composite industry is high carbon footprint. So composite production processes need energy intensive processes. So carbon emissions are high. So as mentioned before, regulations such as CBAM create additional cost to production. That's why it creates a problem in the current model. So in this part, we see that the resource efficiency has critical importance, because the resource efficiency aims to achieve the same or greater productivity while using less raw material. That's one of the solution of the before mentioned problems. So increasing resource efficiency in the composite industry is important to environmental and economic sustainability. So when we can achieve, if we can achieve the resource efficiency in the composite industry, what may happen? The cost could be reduced, since less material and energy usage, uh, the the cost of the production will be reduced, and the environmental impacts will be also reduced, such as carbon emissions and waste amount decrease. And it will be compatible with the regulations such as CBAM and other sustainability related regulations issued by the European Union. So how to achieve the resource efficiency? So one of the solution or some solutions could be following. So alternative raw material use, bio-based resins could be a solution, recycled fibers, and the production techniques could be more efficient, and preventing material waste with additive manufacturing, for example, could be a solution for more sustainable production. Reducing energy consumption with uh, some more efficient methods. So optimize design that consume less resin and fiber. Digitalization, optimization of the production processes with some sensors, monitoring energy and material consumption with big data, for example, or increasing efficiency with artificial intelligence could be possible solutions to achieve resource efficiency in the composite industry. So the circular economy model is critical approach for the composite industry's transition to a sustainable and efficient production approach. So in line with the principles of reduced, reused, and recycled, raw materials consumption should be optimized and efficiency in production processes should be increased, and waste management should be improved for better resource efficiency. Okay, the other part is carbon border adjustment mechanism. So policies aimed at reducing carbon emission with the scope of uh, fighting climate change against climate change are transforming global trade dynamics. One of the regulations issued by the European Union is the CBAM. Um, so it targets the basically energy intensive sectors such as steel, aluminum, cement, fertilizer, hydrogen, electricity, and stuff. But it's also expected that its scope will be expanded in the coming years, and it will also affect the plastic and composite industry at the same time. Uh, so that's why the composite industry should be prepared, transitioning to more sustainable production techniques. And when we look at the main purpose of the CBAM is, we can see that it aims to prevent the carbon leakage and integrate carbon pricing into the global uh, trading system. So what is carbon leakage? Carbon leakage is the indirect increase in total carbon emissions of companies operating in the countries with strict emission regulations by shifting their production to countries with looser environmental policies. So this case both endangers environmental goals and creates competitive inequality for companies within the European area. So main objectives of the CBAM is to prevent carbon leakage, to ensure fair competition between companies in Europe, to encourage green transition. So basically, it aims to ensure that the producers and importers within the European area switch to low carbon production methods by imposing an additional cost depending on the carbon content of the product that are imported. So what is the relationship between CBAM and the European Green Deal? So the European Green Deal is the EU's strategic plan to become climate neutral by 2050. So in this context, the various regulations are being implemented to reduce carbon emissions. So CBAM is one of the critical tools of this transformation and is linked to the European emissions trading system, which is EU's carbon pricing system. So the implementation process is following. Between 2023 and 2025, it's reporting period, which means the companies will report the carbon emissions of imported products, but there will be no financial obligation yet. After 2026, uh, the obligation to purchase CBAM certificates will begin for imports with high carbon content. So that process is expected to gradually realize the integration of carbon pricing into the industries. Okay, then what are the possible impacts of the CBAM and related regulations on composites industry? So currently, CBAM does not directly cover the composite sector, but it's expected to affect the composite industry due to its indirect effects and expansion in scope of the feature. So raw materials such as glass fiber, carbon fiber, and resin are among the carbon intensive sectors due to their high energy consumption. So if these raw materials are included in the scope of the CBAM, which could be, so imports cost will increase and supply chain changes may be required for composite companies also. So that's why low carbon production techniques such as bio-based resins or use of recycled fibers or lower energy processes will become more attractive in the composite industry in the near future. So traditional production methods with high carbon emissions will suffer, or let's say may suffer, a cost disadvantage due to CBAM. That's one of the possible effects on the composite industry. The other one, companies in the EU can gain competitive advantages by investing in production strategies that reduce their carbon footprint. So the demand for low carbon and sustainable composite products may increase. The other possible impact of the composite industry is compliance mandatory for exporting companies. So companies exporting composite materials to Europe so will have to reduce their carbon footprints to ensure the customers' CBAM compliance, even they are not subject to CBAM. So therefore, investing in carbon accounting and reporting processes will become critical. So CBAM is a mechanism that makes carbon pricing mandatory in global trade and accelerates the transformation in carbon-intensive sectors. Although the composite industry is not currently directly included in the scope of the mentioned CBAM, it might have significant impacts on the supply chain and production processes. Therefore, it has a great importance for composite manufacturers to use low carbon raw materials and develop recycling methods and take measures to increase energy efficiency to be advantages in the near future in the composite industry. So that was the end of the webinar one. Thank you for joining our webinar.